Problem number 2 continued. Let's go ahead and graph the line. We've already calculated our data points right there before I got that phone call. Remember that 0 pounds of blueberries cost $0. 10 pounds of blueberries cost $27.50. Now, we don't have $27.50 on our scale. We have to just figure out where it's going to go. I guess about here? Oops, I'm on 20, but that was 10 pounds. Oops. Okay, 10 pounds is $27.50, right about there. Let me get an eraser and erase this so I don't get confused when I draw my line. Okay, now 20 pounds of blueberries is $55. $55, well, this is 48 and this is 60. So I guess $55 is going to be about right here, maybe? And that was 20 pounds. Okay, plot that point on the graph. 30 pounds is $82.50. 30 pounds is $82.50. That'll be right about here. And I started to calculate how much 50 pounds would be when I got a phone call. Let me finish that. 50 pounds times our price per pound, $2.75. Don't forget, our price per pound we calculated in the very beginning. That's $2.75. So 50 pounds of blueberries times $2.75. I really wish my pen tablet wrote a little nicer. That is equal to $82.50. Uh-oh. It says $82.50 here. I have made a mistake because this is 50 pounds. I have the wrong data. This is 50 pounds. That doesn't make sense. I think I need to just double check what I wrote down. 50 pounds times $2.75. Oh no, this was correct. I hope you're taking notes and doing the math too, because I don't always get it right. You guys better double check me. Okay, that was correct for 30. I really lost track of what I was doing when I was interrupted by that phone call. So 50 pounds costs 50 times $2.75 per pound. That costs $137.50. Okay, I'm back on track now. 50 pounds. Uh-oh, look at that. Our scale doesn't even go up that high. I wonder if I can move this GeoGebra graph. I'm going to just... Can I zoom out? Nope, you cannot zoom out. I thought I would check. Okay, so 50 pounds is off the chart. Well, I skipped 40 pounds thinking I could save time. But that might not have been a good idea. Let's go ahead and calculate how much 40 pounds costs. 40 pounds times $2.75 per pound is $110. Let's plot that. Okay, here's 108. Okay, 40 pounds and $110. I guess that's going to be right about here. Now, if I have plotted my points carefully and correctly, they will all fall in a straight line. They must show a linear relationship or else I have done something wrong. Yes. Okay, I did a pretty good job. They fall on a straight line. You don't have this fancy drawing tool, I bet. You're going to need to do this using the GeoGebra tools. So, oops, I didn't mean to delete all that. There we go. Get the point tool. Plot the points that you have calculated. You might have calculated them differently than me. I mean, you could have calculated them for 5 pounds, 15 pounds, 25 pounds, whatever. Then connect your points with a line. If you have drawn them correctly, they will all fall on a line. Okay, let's just look at this a little more. What does this line mean? And why are we calling this y equals k times x? How is that even related? Why are we graphing this? Okay, this is a proportional relationship. That means for every 10 pounds of blueberries you buy, the price increases $27.50. For another 10 pounds of blueberries, the price increases again $27.50. We get that right here. See? $10 10 pounds costs $27.50. Or 1 pound costs $2.75. We call this a proportional relationship. I made a table showing you that for every pound we buy, the price increases at a proportional rate. And that proportion is $2.75 per pound. The $2.75 is your constant of proportionality, K. The equation for this line is y equals $2.75 times x. X is pounds of blueberries. So however many pounds of blueberries you want to buy, insert that number here for x, multiply by $2.75 per pound, and then you get, ding, y equals the cost. Let me put this equation into words that are more familiar. The cost of your blueberries is going to equal $2.75 for every pound you buy, for every pound of blueberries. This is going to be multiplied, so I'm going to draw an asterisk right here. $2.75 times your pounds. So cost is represented by y. The cost equals your constant of proportionality is the price per pound, $2.75. And then the number of pounds, we represent that with the letter x, the variable x. Okay, good job, guys. Now, please don't forget how to use proportional relationships and graphs. The graph shows a representation of this proportional relationship. The equation of the line also represents this proportional relationship. A good idea is to list the data in a table to help you plot the points on the graph, and then you can get the equation of the line.